different way to look at it. Just I'll quickly explain. If you remember, if we have a box like this, a representation of an activity, we can say that there is there is a start of this activity, and then there is a end of this activity, right? This activity can start one day and this activity can end one day, but we have two options. We make an early start of this activity, we call it early start, or we can make a delayed start of this activity. So delayed start, we can have an early finish of this activity and we can have a late finish, early finish and late. So and the activity has got a duration. So this is a symbol that we use. And I think this is not delayed start, this is late. We can say this is late. So this is the notion or notation which is now an activity can start on its scheduled time, which is fine, we have no issue. But an activity can start one day early, 2 days early, based on when I want to start this activity. And it can go, there can be a late start to this activity, which can be one day late, 2 days late. So we have got some flexibility. You remember the concept of lead and lag? Because we can add a lead, which means that we'll start it early, and we can add a lag, which means that we can delay the start of this activity. The same concept applies to the finish dates also. So we can have an early finish of an activity, we can have a late finish of an activity, but the duration is also mentioned here. So this is kind of a notation that also representation is given here for you to understand. This is a representation that an activity has a early start of day one and it has an early finish of day six. And what is the late start? We could have a late start here and we could have a late finish as well. But when you have a forward pass, you determine the early start and early finish of all these activities. Like if you see 1 and 6, these are the early start and early finish for activity A. 7 and 13, these are the early start and early finish of activity A. I mean, this was C and this one A. And then 14 and 15 are early start and early finish of activity T. Similarly, activity B, early start is 1, day 1, early finish is day 4. Activity R, early start is 14, early finish is 16. Activity P, early start is 1 and early finish is 3. Activity U, early start is 4 and U. But how did we determine this? How did we determine these numbers, right? This is important. So let's say we have got a table, okay, and we created our diagram out of a table. So where is the table? Where is Here's sorry. Okay, there's no table, but they gave us a diagram, okay, and they gave us a duration of these activities. Now I need to start somewhere, so I can say if I know activity A is C is for 6 days, and activity B is for 4 days, and activity P is for 3 days. Okay, what can I do? I can say, okay, the project will start on day one, and the earliest an activity C can start is day one. If it is got 6 days to complete, then it will end on the end of the day six. So start of the day one, it will start, and end of the day six, 6 days, 6 days will pass. So earliest this activity can finish is the end of the day six. Gigi, any question? Because it has got 6 days.
It's all right. I'm
You are
listening.
following, right? Similarly, if activity B is for 4 days, earliest it can start is with the start of the project on day one, and it will take 4 days. So it will finish on the end of the day four. And similarly, we are seeing that similar kind of example we saw in the past a while ago, that C, B, and P are all dependent on the predecessor for these three is start. Like with the start of the project, these three activities are starting in parallel. All good. Now, what else? By the way, the formula, you can use the formula to calculate early finish, and the formula is given here. So this is also one way to determine the early finish, right? This is the formula. So let's say I want to calculate early finish for example for activity A, and it is 13, but I don't know that. So I need to see earliest an activity A can start is when an activity A can start. Now, this is important because activity A is dependent on activity C to finish, and activity A is also dependent on activity B to finish, and activity A is also, and activity A is also, and activity A is also dependent on activity P to finish. I have got three activities as predecessor for activity A. So I must be waiting to start activity A until All these three activities are done. Now, which one is the longest activity among C, B, and P? P is finishing in 3 days, B is finishing in 4 days, and C is finishing in 6 days. Although I can be finished by activity P at the end of day 3, can I start A? No, because A is also dependent on B. Okay, let's wait for one more day and B is done. Can I still start activity A? No, I have to wait till activity C is done because activity C will take 6 days. So I will wait for 6 days to ensure A, C, B, and P are all done. Then I will start activity A, which means at the end of 6 day, I am okay to start activity A, which means what is the early start of activity? Possible early start is that the next day, because we already finished the day 6 and now the next day is day 7. So earliest I can start activity A is 7, right? So early start will be 7. Here I will have 7 and duration of this activity is 7. And now 14 minus 1 is 13. Like minus 1 is 13. So 13 is the earliest this activity can finish. This is how we determine this. And this is how we
Can you
determine
repeat
this.
this again?
Sorry?
How you determine 13?
13. How I
Yes.
determine 13? First, you know how I determined 7?
Yeah, I got it.
Okay. Then I use this formula to calculate early finish. Early start plus plus the duration, which is 7. Early start is 7 day and minus 1, which means 7 plus 7 with 14 minus 1 is 30.
Okay,
Now you
got
got
it.
it, Gigi?
Yeah, now I got the three blocks on the
Yes,
top of
yes, that's right.
the thing.
Okay. And one step back, let's see if you can calculate the early finish for activity C. Let's say you don't know early finish is 6. So earliest an activity C can start is on the start of the day 1, right? So day 1, which means 1, then 1 plus 6, which is duration, which is 7, and 7 minus 1 is 6. Clear? Similarly, you can do for B, you can do for now. The tricky one was to determine the early start of A, which you all understood because I explained you that A is dependent on C, B, and P to finish. And C will finish on the end of day 6. So we need to wait until C is done. And then from the start of the day 7, we can start activity A. You guys will be able to put 7 here, right? Okay. Now let's move forward. Let's move forward. Now let's say activity T, when it can start. It is dependent on activity A to finish, and A is finishing on end of day 13. So what is the next day? The next day is start of the day 14 when the activity T can start. Good. When you move forward, you enter the top values like early start and early finish. So what will be the early finish then? 14 plus 2, which is 16 minus 1, 15. So I entered, let's say I am done with defining the early start and early finish for activity T also. The same fashion which we just did. Similarly, now when it comes to R is dependent on A and A is finishing on 13. So 14 will come here and then 14 plus 3, 17 minus 1, 16 will come. Done. Now let's come to P. P will start on day 1. P will start on day 1 and it has 3 days to go. It will finish on 1 plus 3, which is 4 minus 1 at the end of day 3. Now U is dependent on P only. U doesn't depend on B and C. U is dependent on P only. So you can start on the day 4 and then 4 plus 4, 8 minus 1 is the 7 here. Now N is dependent on U only, then N can start on the day 8. 8 plus 6, which is 14 minus 1 is 13. All good. You guys will be able to determine forward pass, which means plot, find out the early start and early finish of each activity and enter on the top of these activities like 1, 6, 7, 13, 14, 15, 1, 4, 14, 16, 1, 3, 4, 7, 8, 30. All good. And we will now understand the backward pass. And the backward pass, you see the empty, these are the empty one, right? We need to determine the late start and late finish also, right? These are still empty. So in the backward pass, we will determine the late start and late finish of these. Now let's go to the next. Any questions so far, Gigi?
It's okay. Thank you.
Oh, now let's move forward to the backward pass. Okay, backward pass. Now in the backward pass, I am interested to know late finish and late start of these, and you can see late finish and late start. It's mentioned over here. So from I need to start now from the end of the project. Earlier, I started in the forward pass. I started from start to end of the project. Now I need to go backward, which means backward pass. So I will start with the end and I'll say, all right, my project has to end on day 16 from the critical path. By the way, I got to know from the forward pass that that day 15th, end of the day 15th, the activity, the end of the day 16, the activity R is finishing and end is dependent on activity R, and R is the critical path activity. So I know that project will finish on the day 16, right? End of the day 16. So how I can calculate my late finish? Late finish is the end of the project, which is 16, because I cannot delay the project. I must finish on the last day of the project. So my late finish of activity T, R, and N would be the end date of the project, which I just determined from the critical path. Because remember, once you determine the critical path, in this example, you already have determined the critical path already. It is plotted here and it is 16. The longest path is 16. So that is C, A, and R, which is the critical path. So you know the duration of your project, which is 16. So you will straight away enter the duration of your latest that these activities can finish is 16. Which activities? These activities. Like the late finish of activity T is 16, the late finish of activity R is 15, the late finish of activity N is 16. It is similar to when we entered the one as the forward pass. We entered like, okay, we will start the activity on the start of the day one. Similarly, when we are coming backward, we are entering the date of the project and date here as the late finish date for these. All good so far? Okay, let's move. Now I need to determine late start then. Then what is the formula? What is the late finish? It is 16. What is the duration? For example, for activity T, what is the duration? Duration is 2 days. So I need to minus 2 and then I need to add 1. So 16 minus 2 is 14 plus 1 is 15. No, 16 minus 2 is 14 plus 1 is 15. Yeah, correct. So this is 15 here. Similarly, for this activity, for R, what will be the case? 16 minus 3, which is 13 plus 1, which is 14. For activity N, what will be the case? 16 minus 6, which is 10 plus 1, which is 11. All good till here? All. Now, it comes to determining late finish of A, then we have a competition between activity this one and this one. Now, now if you remember when we were moving forward, we decided seventh based on the six. Which one is the largest of these activities, right? 6, 4, and 3. We said, okay, since we need to wait for 6 day to finish, then 7 will come here. 4 will not come here. Like we could have said this is 4 instead of 7, but we said no, because we need to wait till C is finished. That's why we said that, okay, 7th will be the earliest start possible. Now, what is the late finish possible for activity A? Because now we need to choose the smallest between the two which it is dependent on. Now 15 and 14, which one is the smallest? 14 is the small. So backward pass, we will say it is 13 here because we are choosing the very next two activities are 14 and 15. So the smallest one we will choose and put 13 here. And then 13 minus 7, it is 6, and 6 plus 1 is 7. So it came 7. Similarly, if we go further backward, now activity C has 1 and one only successor. So we will choose 6 as the latest finish because 7th is the late start of that activity. 6 will come here, and 6 minus 6 is 0 plus 1 is 1. And what else? For this activity, we have again the same situation. 6 will come here, and since 7 is also dependent, B is also dependent on this one. So 6 will come here, and 6 minus 4 is 2 plus 1. So this is the way we calculated our backward pass. Any question?